Okay, it's time for Target 3. Now, Target 3 advertises that it uses state-of-the-art encryption for its password, so it should be a whole lot safer, right? Let's go ahead and dive into check password. That's been a fruitful area of study so far. And let's just scroll down through it and see what it's doing. Typical stack stuff, and it's calling AES 256 main ECB. So AES 256 is a fairly safe symmetric encryption algorithm. So it's encrypting or decrypting something with AES 256 at this point. But let's just look to see what else is going on here. We see that it's doing a prompt, and when it's done, it jumps to 12401243. And here, this is the other prompt, and this is where it's actually calling the other prompt. And so, yes, 401243 is where both of the prompts end up after they run. And it's loading some addresses, and it's calling strcmp. So that's interesting. Let's go ahead and break. I don't know why I can't set a breakpoint there, but I can do this. I'll break on 401251, and I will just tell it to run. And I'm going to type foobar and jump over here. I'm at 401251. So let me jump down there. Okay, so I am in fact at the strcmp. And so what I remember from before is that RSI and RDI are the registers containing the two parameters for the strcmp, and I see that 405320 is the pointer to one of the things, and the other one is the stack variable. So I think I can be pretty sure that 405320 has the password that it's comparing my password against. And sure enough, there's the unencrypted password. So after adding AES 256, the program is still just decrypting the encrypted password and comparing the two plain text passwords. So Harry Houdini with the @ for the A, 0 for the U, and I's for the ones for the I's. So let's just go ahead and try that. H at RRY H 0 U D1 N1. And we're back to the strcmp. I'm just going to hit continue, and the unlock succeeded. So that is obviously not a good way to make use of AES 256 because it decrypted the password and then compared the decrypted password with my password. You would think maybe a better way would at least be to encrypt my password and compare it with the encrypted password. The problem is if I were to go in and trace the call to the AES 256, it's obviously encrypting it with a key. I could find the key there, and I could still just take that key and the encrypted password and decrypt it with an AES 256 routine and be able to get the password that way. For passwords, this is not true of encrypted data where you need to actually recover the plain data. But for passwords, what you want to do is a hash, presumably a secure hash. And if you look up algorithms, there are ones where you hash it several times to make it more complicated. But for a hard-coded password, using a one-way hash and a long password with random letters and digits is probably your best bet, because it's not going to be easy to figure out what value hashes to that. If you use words, even these hacker speak words where you're substituting in 0 for O and 3 for E, they're very susceptible to a dictionary attack. So you want a long password with no discernible words that a dictionary attack is not going to match, with enough letters that it would take an exorbitant amount of time to try to iterate through all the possibilities. And I'm talking 16, 20 characters. You want something long enough that even with a lot of firepower, it would take a long time to break. And it's also, you have to realize that even with that, there's a time limit on how long it's going to hold up before somebody cracks it. But this should serve as an example of the worst way to use something like AES 256. Don't use symmetric encryption for passwords. Use hashes. But even if you're going to use symmetric encryption, at least go the other direction. Even though this is still insecure, of don't decrypt into plain text. At least encrypt the password and then compare the two encrypted passwords. But again, it's if somebody is going to go to the trouble of figuring out that that's what you're doing, it's not going to be a big step to go ahead and find the symmetric key and use that and decrypt your password. So we'll have to see what Target 4 comes up with.